Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on December 31st, 2025, about 5 days ago. It introduces a modular framework designed to automate the creation of large language model agents, achieving state-of-the-art results with over 71% accuracy on WebWalker QA and about 73% on Gaia using open weight models. The paper is titled Youtu-Agent, Scaling Agent Productivity with Automated Generation and Hybrid Policy Optimization. And as we'll see later, the implications for reducing manual engineering costs are quite significant. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the automated generation mechanism. Starting on the left with the user requirement, the process splits into two paradigms shown in the center. The top section depicts workflow mode, a linear pipeline that decomposes intent and synthesizes tools step by step. In contrast, the bottom section shows meta-agent mode, where an architect agent dynamically plans the build process for complex requests. Both paths converge on the right, producing a complete YAML configuration for immediate deployment. So once the agent is built, it needs to learn. Figure 2 details the training-free GRPO mechanism, allowing improvement without updating model weights. On the left, the policy combines a frozen LLM with a mutable memory of experiences. In the center, the agent generates multiple outputs, which reward model scores to distinguish success from failure. The group computation block then distills these results into textual advantages. Finally, the controller at the top uses this feedback to update the experience memory, creating a cycle of continuous self-improvement. While the previous method avoided parameter updates, Figure 3 outlines the comprehensive end-to-end reinforcement learning pipeline for when actual model fine-tuning is required. The left panel displays the RL framework, which manages the heavy lifting, containing the inference backend and the trainer loop that computes loss and updates policy weights. In the center, a connector layer acts as a bridge, using proxies and data stores to synchronize the system components. Finally, the right panel shows the agent framework, where the agent initializes, runs through queries, and computes rewards to feed back into the training cycle. Well, putting those architectures to the test, Figure 4 presents the performance comparison on WebWalker QA. The chart is divided into two groups. The blue bars at the top represent training-free methods, while the gray bars at the bottom show agents specifically trained for the task. The top three bars highlight Youtu-Agent's dominance. Notably, the version powered by DeepSeek v3.1 achieves the highest score, exceeding 70%. This is particularly impressive because it outperforms not only standard baselines like React, but also the specialized, fine-tuned models shown in the lower section. Alright, shifting focus to the construction process, Table 1 compares the two generation methods on the Agent Gen 80 benchmark. The columns track three metrics: configuration validity, tool executability, and task completion. In the first column, workflow mode achieves a perfect 100% in configuration validity, reflecting its robust deterministic nature. However, moving to the final column for task completion, the meta-agent mode pulls ahead with a success rate of nearly 69%. This suggests that while the deterministic approach is safer for setup, the dynamic architect agent is better at solving complex tasks. Next, Table 2 evaluates the cost efficiency of the agent practice module on the AIME math benchmarks. The most striking comparison appears in the learning cost column. The upper rows list standard fine-tuning methods like ZeroTIR and Retool, which require investments between $10,000 and $20,000. In contrast, the bottom rows present the training-free GRPO approach. This method costs only about $18, yet it drives the AM 2025 score up to 73.3%, proving that high performance does not always require a massive budget. Wrapping up, two key takeaways stand out. Youtu-Agent proves that open weight models can achieve state-of-the-art results through automated generation, and it drastically cuts costs using training-free optimization. Broadly, this signals a shift from manual agent crafting to scalable, self-evolving systems. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.